Hello grade 12s, welcome to number patterns once again. Now we need to talk or discuss geometric number patterns. Just a quick recap. When we're doing arithmetic, remember when you're doing arithmetic, you said you can have linear or you can have quadratic. In all these cases, we were looking for what is called a common difference, D. Now, from the word difference, it means you are subtracting, all right? So we're saying you can find the difference by saying term 2 minus term 1, or term 3 minus term 2. That's what we were doing, okay? Now, for geometric, we are looking for what is called a constant ratio, and we use the letter R for that. And so it's almost the same thing as this, but instead of it being a difference with a minus sign, it's a ratio. And the ratios you will be dividing, like A divided by B, or things like B divided by A. These are ratios. A is to B, B is to A. So instead of using a subtraction sign, you are going to be using a division sign. So in theory, we are saying your constant ratio is equal to term 2 divided by term 1. Or you can say your constant ratio is equal to a term 3 divided by a term 2, or term 4 divided by term 3. Now, let me write a few examples, then there's something else I want to explain. Okay, so here are a few set of examples. Then the last one, half, quarter, an eighth, and a 16th. So we said R is equal to term 2 over term 1. We are looking for the constant ratio. R can also be found by saying term 3 divided by term 2, or R can be found by saying term 4 divided by term 3. So let us check. This will become 20, which is term 2 divided by term 1, it's a 10. So 20 divided by 10, we get a 2. Okay, let's check the other one. Term 3 divided by term 2, the third term, first, second, third. 40 divided by term 2 is a 20. 40 divided by 20, you also get a 2. Next, term 4 is 80. Divided by term 3 is 40. 80 divided by 40, that's a 2. So R, or your constant ratio, is 2. What's next? It's this one, 1 sine theta, 1 minus cos squared theta, and sine cubed theta. This sequence was... Now here, we need to simplify something, this. So our sequence is actually 1 sine theta, this is sine squared theta, and this is sine cubed theta. This is from the trig identity. From the trig identity, sine squared theta plus cos squared theta is equal to 1. And this can be simplified to sine squared theta is equal to 1 minus cos squared theta. You did this in grade 11, because in grade 11 you do two trig identities. This one, and sine theta over cos theta equals to tan theta, that's the other one. Alright, so this is our sequence. So what's happening here? R is equal to term 2 divided by term 1. R is equal to term 3 divided by term 2. R is equal to term 4 divided by term 3. Let us check. r equals to term 2 is sine theta divided by term 1 is a 1. So this is just a sine theta. Okay, let's do this one. R equals to term 3. Term 3 is sine squared theta divided by sine theta. This will also just cancel out to sine theta. Okay, I think you also understand this from exponents in grade 11 and grade 10. Sine squared theta is just the same as sine theta times sine theta. And you are dividing with sine theta, so you just cancel these two and you are left with sine theta. That's how we got it. So let's continue on this one. Term 4 is sine cubed theta divided by sine squared theta. This is the same as sine squared theta times sine theta. Hey, sine squared theta times sine theta divided by sine squared theta. Okay, so the sine squared will cancel and you are left only with sine theta. So r is equal to sine theta throughout. So you write r is equals to sine theta. Okay, so the third one, r equals to term 2 over term 1. R is equals to term 3 over term 2. R is equals to term 4 over term 3. R equals to what? Term 2 is number, it's 2 divided by term 1 is 6. This will reduce to 1/3 as a fraction. Okay, R is equals to, let's do this one, term 3 is a 2/3 divided by term 2 is 2. So this will become 2/3 multiplied by a half. Remember, when you change this sign, you invert this side. So this will just simplify to 2 times 1, that's a 2, 3 times 2, that's a 6, and 2 over 6. And 2 over 6 simplifies just to 1/3. Alright, now r equals to term 4 is 2 over 9 divided by term 3 is 2/3. And so r is equals to 2 over 9 multiplied by, then you invert, 3 over 2. R is equals to 2 times 3, that's a 6. And 9 times 2, that's an 18. And you can simplify this just to 1/3. So what are we saying? Our constant ratio, because it's constant, it's the same throughout. Our constant ratio is 1/3. So r is equals to term. Why am I writing these things? Is because whenever you are doing any calculation, when you've got a formula, you should write it down. It's one of those things. It helps you, it guides you, and it also shows whoever is marking your paper that you know what you're doing, rather than something that just pops out of the blue and the marker doesn't know, hey, what's going on here. Okay, so r is equals to, this is a quarter, term 2 divided by term 1 divided by a half, and r is equals to a quarter times 2 over 1. 2 times 1, that's a 2. 4 times 1, that's a 4. And r is equals to a half. Simplify this, you get a half. Now let's do the other one. R equals to, the third term is an eighth divided by second term, it's a quarter. So r is equals to an eighth times, you invert this side, and r is equals to 4 times 1. It's 4. 8 times 1, that's an 8. And this 4 into 8, 2. Also reduces to a half. Okay, the last one, term for divided by term. The fourth term is 1 over 16 divided by the third term, 1/8. So your r is going to be 1 over 16 times 8 over 1, and your r equals to 8 divided by 16. So from here we can say r is equals to half. 8 divided by 16, you get a half. So the constant ratio is a half.